Welcome to our video on subsets, and we're going to start this video with some disappointing news. We're not actually going to talk about sets of subs in this video, but rather subsets as in, well, what is a subset? I'll tell you right now. So let's start with the definition. We say that X is a subset, so it's like a long curved C with a line under it, of Y if everything in X, whoa, that's not how you spell that word. If everything in X is also in Y. And again, the way that we say that is we say X is a subset of Y. Okay, so pretty straightforward. Is an element in X? If so, it has to be in Y if we want the things to be a subset. So let's get some practice. Let's do some examples. We're going to start with a very important example, and these are going to be true or false. And let's say that A, we're just going to be pretty basic here. A is just going to be the set containing the numbers 1, 2, and 3. Okay, so my first question for you. True or false? Is 1 an element of A? Because that's a very important distinction that we have right here, right? We have the idea of a subset, and we have the idea about an element. A subset, these both need to be sets for subset to make sense. Okay, it's in the name, subset. Okay, so for something to be a subset, they both need to be sets. So, and we can have an element, and that doesn't require both things to be sets. They could both be sets, but anyway, that's something else. We'll get into that later when we talk about sets of sets a little bit more. But yeah, here, is 1 an element in A? Yeah. A contains the element of 1. Okay, so yeah, that's true. The element 1 is in the set A. Whereas in B is a different question. Is 1 a subset of A? And so this is what I'm talking about where we have a distinction. 1 cannot be a subset because 1 is not a set. 1 is an element, so it's not the same thing. So this is going to be false because 1 is not a set. So it cannot possibly be a subset. It's a subset if everything in this set is in this set, but this is not a set. So let me show you what is actually a subset. Okay, so if we look at the set 1, the set can, whoa, that's supposed to be a 3. The set containing 1 and 3. Is this a subset of A? Okay, they have to both be sets. Yeah, these are both sets, so that's a good start for being a subset. And let's check the definition. Is every element in this set also in this set? Well, let's check. Is 1 in this set? Yep. Is 3 in this set? Yep. So we're going to say, yes, this is true, right? And it's true because 1 is an element of A, and 3 is also an element in A. Every element in this first set needs to be an element in the second set for us to have subsettery. That's not a word. For us to have a subset. All right, I want to write down a few more, and I want you to pause the video and try to come up with all the answers, and then we'll go through them together. Okay? Is A subset of the set of all letters K such that K's are integers? Remember, integers are like the counting numbers, but they can be negative. I also want you to answer, is the empty set a subset of A? I also want you to look at, is the set containing 1 a subset of A? And I'm running a little out of room, so I'm going to go off the page a bit. The last thing I want you to do is the set containing 1, 2, and 3 a subset of A? So again, pause the video if you haven't already, and do all of these questions, think about them, write down your answers, and we'll go through them together. All right, if you just want to check your answers, you can skip past this part, but if you want an explanation, stick around. So let's start with D. So again, it's a subset if they both need to be sets. So yes, A is a set, and this is a set, so that's a good start. Is everything in A also in here? Well, remember, this is the intentional definition of this second set. The extensional definition, right, would be, the set that contains infinitely many numbers, but they all, look like this. And then it goes on infinitely in the other way as well. So yes, everything in A is also in this blue set. 1 is in this blue set, 2 is in this blue set, and 3 is in that blue set. Yep, that's everything in A. And it is in this, and we do indeed have a subset right here. Okay, so that's going to be true. Everything in A is in that second set. What about the empty set? Again, they're both sets, so we're good on this. Both things are sets. Is everything in the empty set also in A? What do you think about this? And this is where, coming from a computer science background, I think is a lot more helpful than coming from a mathematical background. Computer science is a little bit easier to say because a lot of it's kind of like an if-then statement, right? Or maybe not even an if-then statement. Y'all might have better examples than this, right? But if there's nothing that needs to be satisfied, then we're good to go. So there is nothing in the empty set. So everything in the empty set, which is nothing, is also in A. There's no requirement to be met here. Okay, so this one is true. In fact, the empty set is a subset of any set. The empty set is a subset, I'm going to abuse notation a little bit, of any set. Okay, just because of the definition, it's essentially a tautology. It's always true because there's nothing in the empty set. And again, I do believe it makes a little bit more sense looking at letter E if you write the empty set as a literal empty set. Is everything in here also in here? Yep, there's nothing in there. There's no requirement to satisfy. Let me know if you have confusion about that. There's some cool other ways of visualizing it as well. Letter F, that's also true. Letter F is just like letter C. It's just fewer elements you have to check. What about G? It looks a little weird, but yes, everything that's in A is in A. They're both the set A. Okay, so yes, this is also true. 1 is in A, 2 is in A, and 3 is in A. Everything on the left is also in the set on the right. Okay. And that actually leads us to our next point of another way of talking about set equality. Remember I said that two sets are equal if they have the same extension. And again, that would show you that these two sets are equal. Another way to show that two sets are equal is, I'm going to write this down as a property. Two sets are equal if and only if. So I don't know if I've introduced this notation anymore, but it means if and only if. It just means it goes both ways. So A is equal to B if and only if A is a subset of B, and I'm actually going to write the word and B is also a subset of A. So if everything in the first set is also in the second set, and everything in the second set is also in the first set, well then of course they must be the same set if that's the case. Okay. Again, another way to explain this if and only if, right, is it's two sentences in one. A equals B if this happens, and if this happens, then A equals B. All right, just a little mathematical shorthand. We'll talk more about that probably in our logic chapter that we'll cover later on in this quarter. All right, so last thing to talk about, because again, this does feel a little silly to write, but it is mathematically true, is our last definition of a proper subset. Okay, so I'm going to leave a little blank here for proper subset. Do you have any guesses? This is what a regular subset looks like. Any guesses for what a proper subset is? For if it's a subset, but it doesn't equal the other one? Well, you can maybe come up with it. It's just the same thing, but without the equal sign on the bottom, okay? So that's a proper subset. All right, and basically it just means they're not the same. Okay, so this is A is a subset, but they're not equal. So everything in A is in B, but there's also something in B that's not in A. Okay, so again, if we just look at all of these that were subsets, right? So like C was a proper subset. Oops. C was a proper subset because it was a subset, but it wasn't the whole set. This is a proper subset. This is a proper subset. This is a proper subset. This is not a proper subset, right? So think about proper subsets, right? Is like, let me use a different color here. A subset sign is kind of like a less than or equal to sign in math. A proper subset is like a strictly less than sign in math. Okay, so that's kind of how you can think about it if you want. And that's pretty much the basics of subsets. I'll have some homework problems to show you some other things that you can do with them. I think that's most of the things that I wanted to mention. Let me know if you have questions, and have a good rest of your day.